Greetings to every one of you. Today we are going to discuss another very important and difficult topic from data structures and algorithm, that is B tree. B tree is a specialized M-way tree. M-way tree is a multi-way search tree in which is a generalized version of binary tree that allow for efficient data searching and sorting. That is multi-way tree. So that concept is used in the B tree. So in contrast, if you take the binary search tree, you can have maximum 2 children per node. But in multi-way tree, you can have multi-children per node. See, for example, in B tree, the order M can have maximum m-1 keys and m pointers. For example, if m is equal to 5, so that means you can have, that is keys, 4 keys you can have, key 1, key 2, key 3, key 4. On either side you can have the key pointers. Okay. So only that pointers will point the data. Next important thing regarding the B tree is that B tree is a binary search tree in which data is stored in a sorted order. In the sense, the lesser value will be stored in the left hand side and the greater value will be stored in the right hand side of the root node. For example, you have 3 set of data, 3 number of data. See, for example, 15 is the root node and the next value is 20, so that will be stored in right hand side. The 10 is a lesser value than the 15, so that it is stored in the left hand side. All the leaf nodes must be in the same level. That is another important property of this B tree. Next, a very important note regarding the B tree and binary tree is that, so the binary tree can be, that is used to access data when the data is available or stored in the high speed memory devices like the main memory or RAM. If the amount of data is very small and the speed of the device is very high, so that being the case, we can make use of this binary trees. But whereas if the amount of data is very large and accessing speed of the device is very slow, that being the case, we can make use of the B trees. Okay, so B trees can be, that is used when data is stored on the devices, secondary devices like the disk. Large data and the speed of the device is very low. Next advanced concept of the B tree is B plus trees. So there is some differences between the B tree and B plus trees. Just let me explain. B plus trees are nothing but the descendant of the B tree. So all the leaves, as far the B plus tree is concerned, all the leaf nodes are at the same distance from the root node. That is one particular property. Then all the leaf nodes form a linked list. But whereas in B tree we don't have that linked list. But in B plus tree, the final node, the terminal nodes, all these nodes will form a linked list. And similarly, it has a duplicate of all keys in the leaf nodes. So though you have the keys available in the upper nodes, those key values will be copied in the leaf nodes. So these are some of the properties you should remember for this B tree. That is how B plus tree. How B plus tree differ from the B tree. It is an advancement of B tree. Now I move on to, that is how to create a B tree for a given set of data. Similarly, for the minimum number of children, it is m by 2. That is, for example, if your order is equal to, that is 5. The minimum number of children is m by 2, that is 5 by 2, it is nothing but 2.5, that is 3. And similarly, the minimum number of keys, it is m minus 2 minus 1, it is 3 minus 1, it is nothing but 2. This is minimum. As for maximum concern, that is m is order of the B tree is m is equal to 5. That means you can have, that is m number of pointers, and you can have m minus 1 number of keys. So for our problem, we will consider the order of B tree with 4. So set of data are available here. These are the set of the data. This is the set of the data. This 12, 20, 40, 50, 60, 70, 80, 30, 36, 6 and 16. So here m is equal to 4. So automatically this m minus 1 is equal to, that is 3, and m divided by 2 is equal to, that is it is nothing but 2. Okay, so these are the values we should remember. First would like to, that is insert the data, insert this 12. So 12 is get inserted, and the next element is 20. 20 can be, that is inserted. The next value is 40, that can also be inserted. So as I said, it is order of m, so that we can have only, that is 3 keys per node. Okay. So now the next value is 50, insert 50. We are going to insert the value 50. So what happens now, actually it is 12, 20, 40, 50. So which exceeds the limits. So maximum limit is that is 3. Since this exceeds the limit, so what you have to do, you have to take the median value. So that median is actually, we calculated here, that is 2. So after 2, that is 1, 2. So this is the median value. So take this value in the root. This is root, and store the values which are lesser than this 40, that is 12 and 20 will be stored on left hand side. Similarly, the 50 will be stored in right hand side. So this is how, that is 50 is get inserted. Now the next value is 60. Insert 60. 60 can be, that is inserted. Take the value, just to compare it with the root value. If the value is greater than the root value, take it to the right hand side. So 60 will be inserted here. Similarly, the next value is 70. Insert 70. Again take the value, compare it with the root node. If it is greater, take it to the right side. If it is lesser, bring it to the left hand side. So again 50, it is greater, so automatically it will be stored in the right hand side. The next value is 80. We have to insert this value. So compare this value with the root value. It is greater, so naturally it will go to the right hand side, but which exceeds the limits. So we have to do the process like that is 50, 60, this is 70 and this is 80. So what will happen, we have to find out the median. So 1, 2, the third node, we have to, that is take the 70 in the root and split these values. 50 and 60 will come to, that is the left hand side, and this will come to, that is 80 will come to the right hand side. Is that okay? So this is how we can insert, that is 80 is here. Now this value, what actually you have, you got this value, that is 70, and that must be that is taken to the root node. So what actually we have 40 here, so this 70 should be that is added in the root node, the level 1, and here lesser than that is 40 we have two values, that is it is nothing but 12 and 20, and similarly that is again that is more than 40, it is 50 and 60, and then more than that is 70, it is nothing but 80. Is that clear? Okay. So after splitting this value, you have to take this value, you have to send this node to the root, okay, to parent, and accordingly you have to adjust the values, remaining values. Now the next value, what actually we have to, that is insert, it is after 80 it is 30. So insert 30. So where will insert? Compare this with the first one, that is 40, it is lesser than 40, so it can be that is inserted here. Okay, so as a result we'll have the value that is this is 40 and this is 30. It can be that is inserted here. This is 12, 20, and this is 30. And similarly, after 40, you'll have the values, that is 50 and 60. After 70, you have this 80, right hand side of 70. Okay, so 30 is get inserted. Now what is the next value? That is 36. 36 we have to insert. So again 36 that is lesser than this 40. So what will happen? It will be that is get inserted only here. So as a result you have the value, that is it is 12, 20, and this is 30, then 36. Okay, so now take the median. If you compare, that is after third node is 30 only, so 30 is the median, so 30, and left hand side we will have 12 and 20, and right hand side we will have this 36. So now what you have to do, you have to take this value, that is 30, to the root. So here you have to take it. Okay, then after 30 you have to fix this value according to this the value, that is 30. So here you have values, that is 30, 40 and 70. Okay, so you fix the value of this 30. You have this 12 and 20. Okay, then on right hand side you will have this 36. Similarly for 40, right of 40 you have this 50 and 60. Then similarly last value, that is 80. Okay, so this is how we can insert. So after inserting, that is 30, these are the adjustments that is made. So our next value is 6, that we have to, that is insert 6. So this value will be get inserted only here. Okay, so this value will be get inserted only here, which will not make any, that is, change in the tree. The last value which we are going to insert is 16. So 16 can be, that is inserted only in this node. So already we have 3 nodes. If you insert 16, it will be inserted here. So totally there are 4 nodes, 4 keys are available. So you have to find out the median. So 16 is the median. So on left side you will get 6 and 12, on right side you will get 20. So what you have to do now, you have to take this node, that is 16, to the root node, but again already there are 3 keys are available. So if you add this value, that is 16, 30, 40 and 70, we have to, that is do the same alteration here. So what will happen, the 40 is the median, so 40 is the median, and this 16 and 30 will come to left side, and the 70 goes to right side. Okay, so this portion is over. What you have to do, you have to, that is do the remaining, you have to copy the remaining values. So after 16 you will get the values, that is this 6 and 12 will come here. Then one more node is here. After 16, left hand side of 16 will have 6 and 12, and right side will have 20. Similarly, on right side of 30 you will get 36, and left side of 70 you will get two keys, that is 50 and 60, and right side of 70 will get 80. So which is the final output? This is the final output of this B tree for the given set of data. I hope you understood the concept, and you can find that see all these leaf nodes are in the same level. So that is one of the important properties of the B tree. I hope you understood the concept. Thank you very much.